We will solve different types of gate questions on Newton-Raphson method. Please like, share and subscribe this particular channel. Let us start now. Now come to the question. The question is equation e power x minus 1 is equal to 0 is required to be solved using Newton's method with an initial guess x naught is equal to minus 1. Then after one step of Newton's method, estimate x1 of the solution will be given by. It's an a GIT 2008 question, right? First we understand the question. They're saying that the equation e power x minus 1. So we can say that the equation f of x is equal to e power x minus 1, right? Again they are saying you have to solve by using a Newton's method. Formula for the Newton's method is nothing but x of I plus 1 is equal to x of I minus f of x of I by f dash of x of I, right? Now they are given the initial guess x naught is equal to minus 1. They consider that I is equal to 0 and they given the x naught is equal to minus 1. Now they are asking for the one step of a Newton's method. Okay, the x1 value would be how much we have to find it out. So we have to find the value of x1 is equal to how much. Now this one I is equal to 0, then it becomes x1 is equal to x naught minus f of x naught by f dash of x naught, right? F of x naught is equal to nothing but e power x minus 1. So it becomes x naught minus e power x naught minus 1 by f dash means just differentiation of e power x minus 1. So it becomes e power x naught only, right? So but x naught is nothing but minus 1. So just substitute the value we get as minus 1 minus e power minus 1 by e power minus 1, which is equal to nothing but it becomes minus 1 minus e power minus 1 into e, right? So it is equal to minus 1 minus 1 minus e, which is equal to nothing but minus 2 plus e. You know that e value is equal to nothing but 2.71828, right? So minus 2 means it becomes 0.71828. So answer is option A. Come to the next question. The following equation is to be numerically solved using the Newton-Raphson method. X cube plus 4x minus 9 is equal to 0. The iterative equation for this purpose is, again they are saying k is nothing but indicates a iterative level. But we consider I as an iterative level, right? Now I is nothing but we have to consider as an a k. That's it. They given the function here. So f of x is equal to x cube plus 4x minus 9, right? And Newton-Raphson method formula is but x of k plus 1 is equal to x of k minus f of x of k by f dash of x of k. So we have to find an equation, iterative equation of it. So just solve it. Then we get x of k plus 1 is equal to x of k minus f of x of k is not but just substitute the values here. Then we get that as x of k cube plus 4x of k minus 9, right, by f dash of it. Okay, just we have to find first f dash of x is how much it becomes 3x square plus 4, right? So f dash of x of k it becomes 3x of k square plus 4. So now just take an LCM. So it becomes 3x of k cube plus 4x of k. So remove the brackets and take the minus inside. Then it becomes minus x of k cube minus 4x of k plus 9 whole divided by 3x of k square plus 4. Yeah, plus 4x minus 4x could cancel and it becomes 2x of k cube plus 9 by 3x of k square plus 4, which is nothing but x of k plus 1. So iterative equation is nothing but option A. Come to next question. The question is, we wish to solve x square minus 2 is equal to 0 by Newton-Raphson technique. Let the initial guess be x naught is equal to 1.0 and the subsequent estimate of x, that is x1 will be. Okay, it's nothing but the same as a Newton-Raphson method. They are given the function here. So they are given the function f of x is equal to x square minus 2. Right. Again they are given the x naught value is equal to 1. They are asking for finding the value of x1. x1 is equal to how much? Right. For this one Newton-Raphson method, we know the formula for x of 1 is equal to x naught minus f of x naught by f dash of x naught. Right. So first we're defining the f dash of x. Here f dash of x is equal to nothing but it becomes, differentiate this one equation, it becomes 2x. So all the values we know it, so just substitute it. It becomes x naught minus f of x naught is x naught square minus 2 by 2x naught. Right. Again they given that x naught is nothing but 1. So it becomes 1 minus 2 by 2, which is equal to nothing but it becomes 1 minus plus 1 by 2, which is equal to 3 by 2, which is equal to 1.5. So answer the option B. Come to next question. Okay, we have to answer 2 points, 1 and 2. Right. Now question is given that given a greater than 0, we wish to calculate its reciprocal value 1 by a by using Newton-Raphson method for f of x is equal to 0. The Newton-Raphson algorithm for the function will be, okay, what will the formula for finding the reciprocal of 1 by a, right? Now again they are saying for a is equal to 7, starting value x naught is equal to 0.02. The first two iteratives will be, okay. Now iterations we have to find it out. We'll be going on to first question now. In this one we have to find the reciprocal of an a, which is nothing but 1 by a. For Newton-Raphson method, we know the formula of it, right? If you have something like pth root of n, then the formula is nothing but x of k plus 1 is equal to p minus 1 x of k power p plus n by p into x of k power p minus 1, right? This is a general formula to find the square root of any number, right? But it is given that you have to find it for 1 by a. So this one is equal to nothing but a power minus 1. Then we can say that p is equal to minus 1 and n is equal to nothing but a. So just substitute the values here. Then we get as it becomes minus 2, right? Minus 1 minus 2, it becomes minus 2 x of k power minus 1 plus a by minus 1 x of k power minus 2, right? Remove all the minuses first, it becomes minus, right? So which is equal to nothing but 2 into x of k power minus 1 minus a into, it becomes x of k square, which is equal to 2 into x of k minus a into x of k square. So which of them satisfy is nothing but option C. Now come to the second question. They given that a is equal to 7, x naught is equal to 0.2. We have to find the first two iterations. So we have to find the value of x1 and x2, right? So first we'll find the value of x1. We know the formula of it, right? X of k plus 1 is equal to 2 into x of k minus a into x of k square. So given the initial value x naught is equal to 0.2 and a is equal to nothing but 7. Here k value would become 0. So we have to find the value of x1 first. Then x1 is equal to nothing but 2 into x of k is 0.2 minus 7 into 0.2 square. It becomes 0.4 minus 0.28, which is equal to 0.12. So option C or B will be satisfied, right? So we define the value of an x2 again. Then x2 is equal to x1 value, we know it, right? So it becomes 2 into x of 1 becomes 0.12 minus 7 into 0.12 square. We get the value as nothing but use a calculator. We get the value as 0.1392. So answer is option B. I'm going to the next question. The question is the square root of any number n is to be obtained by applying the Newton-Raphson iterations to the equation x square minus n is equal to 0. If I denote the iteration index, then correct iteration scheme will be, okay. Now they are given that x square minus n is equal to 0. So x square minus n is equal to 0. Then we can say that x is equal to nothing but square root of n. Now we have to find the square root of an n, right? For this one, Newton-Raphson method, we know the formula of it is nothing but x of I plus 1 is equal to p minus 1 x of I power p plus n by p into x of I power p minus 1, right? So here is nothing but pth root of an n is in a formula. So here p is equal to nothing but 2, right? And n is equal to nothing but n only. So just up to the values here, we get as 2 minus 1 x of I power 2 plus n by 2 into x of I 2 minus 1, right? So which is equal to x of I square plus n by 2 into x of I. So take 1 by 2 common, so it becomes 1 by 2 into x of I plus n by x of I. So which of the options satisfy is nothing but option A. So answer option A. Next question. The question is the recursion relation to solve x is equal to e power minus x using Newton-Raphson method is, okay. What they are saying nothing but we have to find the iteration relationship for the function x is equal to e power minus x. So we can consider f of x is equal to nothing but x minus e power minus x. The Newton-Raphson method formula is given as x of n plus 1 is equal to x of n minus f of x of n by f dash of x of n, right? Now we have to find the value of dash of x, and it becomes f dash of x is equal to nothing but 1 plus e power minus x. So just substitute the values here, we get as x of n minus x minus e power minus x of n by 1 plus e power minus x of n, right? So which is equal to nothing but it becomes, take an LCM, x of n into 1 plus e power minus x of n minus x of n minus e power minus x of n, right? So by 1 plus e power minus x of n. So substitute the values here, we get as x of n plus e power minus x of n into x of n minus x of n plus e power minus x of n by 1 plus e power minus x of n, right? Plus and minus get cancelled. So which is equal to 1 plus x of n into e power minus x of n by 1 plus e power minus x of n. So which of them satisfy the options is not an option C. So answer is option C. Now come to the next question. The question is identify the Newton-Raphson iteration scheme to find the square root of 2. Okay. What they are doing is nothing but they find the pth root of an n by Newton-Raphson method. You know that pth root of an n formula is given as x of n plus 1 is equal to p minus 1 x of n power p plus n by p into x of n power p minus 1, right? Now we have to find the square root of 2. Then it is nothing but 2 square root of 2, which is equal to nothing but 2 power 1 by 2, right? So p is equal to nothing but 2, right? N is equal to nothing but 2, right? So substitute the values of it here. Then becomes 2 minus 1 x of n square plus 2 by 2 into x of n power 2 minus 1, which is equal to x of n square plus 2 by 2x of n. Take 1 by 2 common, it becomes 1 by 2 into x of n plus 2 by x of n. So which of them satisfy is nothing but option A. Now come to the next question. The question is starting from x naught is equal to 1, one step from Newton-Raphson method is solving the equation q plus 3x minus 7 is equal to 0. Given the next value of an x1 as, okay, what they're saying, they're given the initial condition x naught is equal to 1. X naught is equal to 1. Now we have to solve the equation, right? So we consider f of x is equal to x cube plus 3x minus 7, right? Again we have to find the value of x1. x1 is equal to how much? We have to find it out by Newton-Raphson method. The general formula of it is nothing but x1 is equal to x naught minus f of x naught by f dash of x naught, right? First we want to find the value of f dash of x naught, which is equal to 3x square plus 3. Just substitute the values here, we get as x naught minus x naught cube plus 3x naught minus 7, right, by 3 x naught square plus 3. You know the x naught value is nothing but 1, so it becomes 1 minus 1 plus 3 minus 7 by 3 plus 3, which is equal to nothing but it becomes 1 plus 3 by 6. One side goes by 2 side, which is equal to 3 by 2, which is equal to 1.5. So answer option C. The steps of Newton-Raphson method for solving a nonlinear equation is given as x of k plus 1 is equal to 2 by 3 x of k plus 5 by 3 x of k power minus 2. Starting with suitable initial value as k tends to infinity, the iterate x of k tends to, okay. Instead of giving a function, they directly substitute the value of a function and given the values. As we know that the formula for Newton-Raphson method, right, is nothing but x of k plus 1 is equal to x of k minus f of x of k by f dash of x of k. Now instead of giving f of x of k, right, they directly substitute the value and given it. Now we have to find the value of x of k. Okay, and it tends to how much we have to find it out. Now we'll be solving this particular equation in this particular formula format. Okay, it is given thus x of k plus 1 is equal to 2 by 3 x of k plus 5 by 3 x of k power minus 2. Okay, first we'll be solving the value such that we'll be getting the value of x of k plus 1 minus x of k is equal to minus of f of x of k by f dash of x of k, right? So substitute the values. So we can write this one as nothing but x of k plus 1 is equal to 1 minus 1 by 3 x of k plus 5 by 3 x of k power minus 2. So substitute the values here. Then we can write x of k plus 1 minus x of k is equal to minus 1 by 3 x of k plus 5 by 3 x of k power minus 2. This one is nothing but minus f of x of k by f dash of x of k. So we can write it right, f of x of k by f dash of x of k is equal to minus get cancelled. So it becomes 1 by 3 x of k minus 5 by 3 x of k power minus 2. Now this one we can write it this one as 1 by 3 x of k minus 5 by 3 x of k square, right, as it is minus 2. So which is equal to nothing but take an LCM, it becomes x of k cube minus 5 by 3 times of x of k square. So we can directly see that if f of x is equal to x cube minus 5, then f dash is equal to 3x square, right? So we can consider f of x of k is equal to x of k cube minus 5. Now k tends to infinity. You have to find the value x of k. So directly we can consider x of k cube is equal to nothing but 5. If you equate it to 0, okay, as it is tending to infinity, then x of k is equal to nothing but cube root of 5, which is equal to 1.7099. So answer option A. Come to next question. Consider a series x of n plus 1 is equal to x of n by 2 plus 9 by x of n and x naught is equal to 0.5 obtained from the Newton-Raphson method. This series converges to, okay, it is a similar type of question. Okay, instead of giving in a function, they are given the values of it by substituting it in a formula, right? As we know, the formula for Newton-Raphson method is nothing but x of n plus 1 is equal to x of n minus f of x of n by f dash of x of n. Now this one is given as nothing but equal to x of n by 2 plus 9 by 8 x of n, right? Now we have to find the value of an value of an x of n when it tends to an infinity, right? It is given as series converges to, okay, and initial condition is given as x naught is equal to 0.5, but there is no need of this particular value. Now we'll be substituting the value such that we'll be getting a value of an f of x n is equal to how much? We'll be getting it. For this, what you do is nothing but find the value of x of n plus 1 minus x of n, which is equal to nothing but minus f of x of n by f dash of x of n, right? So we can write this one as nothing but 1 minus 1 by 2 x of n plus 9 by 8 x of n, right? From this one, we can consider this one as nothing but x of n plus 1 minus x of n is equal to minus 1 by 2 x of n plus 9 by 8 x of n, right? Now this value is equal to nothing but minus f of x by f dash of x, right? So it becomes f of x of n by f dash of x of n is equal to nothing but it becomes 1 by 2 x of n minus 9 by 8 x of n. Taken LCM, it becomes 4 x of n square minus 9 by 8 x of n, right? So if you consider that f of x of n is equal to 4 into x of n square minus 9, then we can get f dash of x of n is equal to 8 x of n, right? It satisfies. So we can consider 4 into x of n square minus 9 is equal to 0 as extend to infinity, right? Then x of n is equal to nothing. This one is equal to nothing but square root of 9 by 4, right? Which is equal to 3 by 2, which is equal to 1.5. So answer the option A. Now coming to the next question. The question is, a piecewise linear function f of x is plotted using a thick solid lines in the figure below. The plot is drawn to scale. If we use a Newton-Raphson method to find the roots of f of x is equal to 0 using x0, x1, x2 respectively as initial guesses, the roots obtained would be. Okay. First understand the question properly. Okay. Given the function, linear function f of x, and you have to use a Newton-Raphson method and find the roots such that f of x is equal to 0. And we have to find the roots of x0, x1 and x2, right? In general, in Newton-Raphson method, what we do is nothing but, if you consider a graph here, okay, this is nothing but say x0. Then what we do in Newton-Raphson method is nothing but, we draw a tangent to it, say x1, and we define the root of it. Say this is nothing but root, say alpha, such that f of alpha is equal to 0, right? By using a Newton-Raphson method, we will be drawing a tangent to it and you're getting the nearest root of it, right? And formula of a Newton-Raphson method is given as x1 is equal to nothing but x0 minus f of x by f dash of x, right? Then again from x1, we'll be drawing again a tangent and find the value of an alpha. But in this particular question, f of x is not given, but the graph is being given. So graphically, we have to find the roots of a function, right? So we have to find the value of x0, x1, and x2, right? So first we divide the value of an x0. If you consider this point as an A, this point as an a B, this point as an a C, then this point as an a D, this point as an a E. Okay. First what we do is nothing but from x0, okay, draw a tangent to it. Then it will touching this particular x-axis at particular point. You have to find this particular point first. For this one, we're defining the function from A to B. Okay, we're going with x0 first. And from A to B, we're defining the function such that y is equal to mx plus c, right? And the points are given as nothing but 0, 1 and 0 0.5, 0 0.5. So we'll just solve the value of 0 and 1 here. This one becomes 1, this is 0 and plus c, right? Then we get c is equal to nothing but 1, right? Again 0 0.5, 0 0.5. This is 0 0.5 is equal to 0 0.5 m plus 1, right? Then we get m is equal to nothing but minus 1. So equation we got it as nothing but y is equal to minus x plus 1, right? Now it will be touching the x-axis. So if you consider only the x-axis, then y is equal to 0. Then x is equal to nothing but 1. So it will be touching this particular point at a point 1. Now it will be drawing in a straight line to it. It is touching this particular point from C to D, right? So the nearest root of it nothing but it will touching the x-axis at 1.3. So directly you can say that x0 is equal to 1.3. We got the value of x0, which is equal to 1.3. Now we'll be finding the value of an x1. If you consider x1 here, okay, then draw a straight line to it is already given here. Then the point to it is nothing but from B to C, it will touching the point at 0.6. So x1 is equal to nothing but 0.6. Now coming to x2 value. It is from D to E, in between D to E, right? Now we'll be drawing a one more tangent to it, and it will touching this particular point at this particular x-axis. Now we're defining the function of it from D to E, right? Given us y is equal to mx plus c, and the points are given us 2.05 comma 1 and 1.55 comma 0.5, right? Then it be given as nothing but just substitute the values here. We get 1 is equal to 2.05 m plus e. The values 0.5 is equal to 1.55 m plus c. So just subtract the values, minus just to get cancelled, which is equal to get us 0.5 m is equal to 0.5. Then m value is equal to nothing but get us 1. As m is equal to 1, then we get 1 is equal to 2.05 m plus c, right? M is equal to 1, and c we get as minus 1.05. So just substitute the values here, then you get y is equal to x minus 1.05. So in the x-axis, it will be meeting at a point at x-axis, right? And y is equal to nothing but 0. Then x is equal to nothing but 1.05. So it meets at the point 1.05. Then I draw a tangent to it. There's a tangent to it. Then yes to point to it nothing but 1.3. So we can say that x2 is equal to nothing but 1.3. So answer is nothing but x0 should be 1.3, x1 is 0.6, and x3 is 1.3, right? So it is satisfied in the option D. So answer is option D.